Today we'll be talking about scientific notation, which is a way of writing really long numbers in a more condensed way. The first thing we're going to take a look at is these numbers are written in scientific notation. Okay, recognize that these numbers out in front are all between 1 and 10. Okay, there can only be one digit to the left of the decimal. So it can be equal to 1 all the way up to 10, but not equal to 10. So 9.98 would work, but not 10 itself, okay, because there needs to be only one digit before the decimal, okay? And when we look at our exponents, the positive exponent indicates that you're going to have a number larger than 1, and a negative exponent indicates that you're going to have a number smaller than 1. Okay, so let's take a look at this very first one. We have 2 and 3/10 times 10 to the 4th power. Okay, this is the same as doing 2.3 times 10,000. Okay, 10 to the 4th power is 10,000. And if you type this in the calculator, you are going to get 23,000. Okay, and I want you to recognize that this decimal place moves all the way to the end here. Okay, you can also recognize it moved 1, 2, 3, 4 decimal places. Okay, so and that happens to be the same number as the exponent. Okay, so 2.3 times 10 to the 4th power is 2.3 times 10,000 is going to give you 23,000. Let's take a look at number 2. 9.45 times 10 to the 6th power. If we use the same trick we found out in number 1 about moving our decimal places, again recognizing that the positive 6 is going to give us a number larger than 1, which indicates that we move the decimal in a direction that's going to give us a larger number. So we have 9.45 times 10 to the power 6, so we're going to move that decimal 1, 2, 3, 4, 5, 6 places. And that is going to give us 9,450,000. 945 followed by 4 zeros. Okay, and again, remember that decimal is at the end now as it moves. Okay, and you can check that in your calculator. Okay, now number 3 and 4, we have negative exponents here, which indicates that we are going to end up with a number smaller than 1. So we have 4.13, and we're going to use the same trick as we used in numbers 1 and 2, but instead of moving my decimal to create a larger number, I'm going to move my decimal to create a smaller number. And I'm going to move the same number of decimal places as the exponent tells me. So I'm going to go 1, 2, 3, 4, 5 places. And my decimal becomes there, and I fill in with zeros, just as we did above. Okay, and that's going to give you decimal 1, 2, 3, 4 zeros, the number 4, 1, 3. It's important that you include all of the numbers that they gave you in the original problem there. Okay, unless it tells you to estimate. Okay, and number 4, okay, 5.5 times 10 to the negative 4th power. So again, move my decimal in a direction to create a smaller number. Okay, 1, 2, 3, 4. My decimal goes in front. Okay, these next 4 problems, numbers 5 through 8, talk about the way that scientific notation looks in your calculator, and they use this E notation. So this E notation just means times 10 to the power of. Okay, it's a shorthand way for your calculator to be able to do this without having to type out all of it. Okay, so this would be 3.6 times 10 to the 5th power. Okay, 1.37e7 would be 1.37 times 10 to the power of positive 7. Okay, and you can try those next two on your own. Now these next couple problems, we are going to go from standard form back into scientific notation. And we're going to use the same information we used above about having positive and negative exponents with numbers larger than 1 versus smaller than 1 to help us determine what our exponent is going to be. So for instance, in this very first one, my number here is larger than 1. It's 3,230,000. Okay, this indicates to me that I'm going to have a positive exponent. Okay, and then I need a number between 1 and 10, remember. It can only have one digit to the left of the decimal, so I'm going to put my decimal all the way here for my scientific notation. Okay, so I have 3 point, and then I'm only going to include the digits greater than 1 unless there is another digit on the other side of 1. So for instance, if I have 2.104, I would need to include that 0. But if I have more zeros after, I don't need these ones. Okay, those are called significant figures when you get into science class. Okay, so 3.23, and again, I do not need the zeros because they don't change the value of my number in decimal form, times 10 to the power of, again, I started out as a number larger than 1, so I'm going to have a positive exponent. And then I'm just going to count the number of times I moved my decimal. 1, 2, 3, 4, 5, and 6. So I have to the power of 6. Okay, 3.23 times 10 to the 6th power. Okay. We'll do the same thing down here on number 11. Again, it is larger than 1, okay? And I'm going to take that decimal and put it all the way down here because, again, only one digit to the left of the decimal when I write in scientific notation. And I'm going to include the 1, 1, and the 7 because those are all significant figures, times 10 to the power of, let's see how many decimals I moved. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and you can see in a number like that how this would be much simpler to write than all of that. Okay. All right, now 10 and 12, notice these numbers are between 0 and 1, so they're smaller than 1, which indicates to me that I'm going to have a negative exponent. Again, I'm going to find a location to put my decimal that gives me a number between 1 and 10, where I'm only going to have one digit to the left of the decimal. And that's going to be here between the 8 and the 5, because remember, we're going to drop all these zeros. Okay, so I have 8.5 times 10 to the negative exponent. So I go ahead and put my negative sign, and then I can count how many decimal places I moved it. 1, 2, 3, 4, 5, and 6. Okay, don't forget to move it to the other side of that 8, okay, to get a full 6. Some people miss that, so don't make that mistake. 10 to the negative 6th power. Okay, and last one here, my decimal is going to go between the 9 and the 7. Okay, and then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 9.72 times 10 to the, again, negative exponent because it is a number between 0 and 1, negative 8. Now these next questions are going to discuss the best way to represent certain numbers, whether using scientific notation or standard notation would be better for certain circumstances. So let's take a look at number 13. A bull weighs 1,700 pounds. Is it more appropriate to express the bull's weight as 1,700 pounds or 2.72 times 10 to the fourth ounces? Okay, and why? Okay, well, 17,000 or 1,700 pounds, okay, describing a bull's weight in ounces is a very tiny measurement, right? Okay, so we want to use a larger measurement that makes the most sense. So 1,700 pounds or 1,700 pounds would make the most sense for this. Now, if you're talking about a baby, a tiny little thing, you might talk in ounces, right? 15 ounces, 16 ounces, okay? All right, because they're not even a full pound yet necessarily, okay? Now, number 14, let's take a look here. A diameter of a quarter is 24.26 millimeters. Is it more appropriate to, okay, number 14, the diameter of a quarter is 24.26 millimeters. Is it more appropriate to post the diameter as 24.26 millimeters or kilometers? Remember, kilometers is a really big measurement, okay? It's like a mile, all right? Well, a quarter is not very large at all. So using millimeters is actually the more appropriate of those, okay? Okay, and these next couple are going to talk about estimating numbers in scientific notation. So instead of writing out this 42,786,950 milliliters of shampoo, okay, we're just going to round this to the nearest, let's say 4.3. So I would put my decimal here between the 4 and the 2, and then I can round from there. So I might get 4.3 times 10 to the power of, and it's going to be approximately equal to. All right, and we move it 1, 2, 3, 4, 5, 6, 7 spaces. And again, that number is larger than 1, so it is that positive exponent, okay, is approximately that, okay? And then the distance from Earth to the sun is this big old number, okay? Again, I can put my decimal between the 1 and the 4 there, and I would get approximately 1.5 times 10 to the power of, again, positive exponent, move it 6, 7, 8 times, okay? Just round to the nearest tenth or hundredth, okay?